Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, it's the first Tuesday of 2024. Happy New Year. I hope you had a wonderful holiday season. Now, next week, we're going to take a look backwards at 2023. It was a great year at Horner. And then the following week, we're going to take a look forward to see what you can expect in 2024. You won't want to miss those programs. But today, we've got another technical topic which we think you'll find informative. Here it is. Setting the default I/O state for Horner I/O. So what is the default I/O state and why does it matter? We're going to answer those questions today. So without further introduction, let's take a look at how we're breaking down today's topic. Okay, of course, we're going to start by defining what is the default I/O state. When does it come into play? Should you ever change it? If so, how? And of course, we're going to have plenty of bench demonstrations. So what is the default I/O state? Well, I'm defining the default I/O state as the on-off status of PLC I/O, specifically digital and analog outputs when the PLC is powered up but not actively in control of the I/O. And the default I/O state feature is one safeguard intended to ensure that the machine is in a safe state even when the PLC is not fully in control. Okay, so when does the default I/O state come into play? Well, let's take a look at a scenario where we have a PLC or an OCS all-in-one controller that has built-in I/O. Everything's powered up, but the PLC is not in run mode. So what is the default state of the outputs in that scenario? Let's take a look at a scenario where we have remote I/O, because there's more situations where the PLC is not fully in control. Well, the remote I/O could be powered up, but again, the PLC might not be in run mode. The remote I/O could be powered up, but the PLC is powered down. Or there could just be a communications issue, maybe a broken cable or something else, between the remote I/O and the PLC. So those are all scenarios where the remote I/O is powered up, but the PLC is not in control. Now, the whole idea behind the default I/O state feature is to add a mechanism that can improve the safety of your control system. And generally, when it comes to doing harm, whether that's bodily harm or machine damage, it's generally output devices that, if they're not controlled properly, can cause the most problems. So when we're talking about default I/O state, we're talking about the state of output devices. Now, the idea behind the default I/O state is for it to put the outputs to the safest state when the PLC is not actively in control. Now, if we're supposedly improving safety using this feature, how is it doing that? Well, we just talked about how it's doing it. However, it's not the only feature or the only mechanism for machine safety, of course. There are plenty of other approaches to safety that need to be in play, such as e-stop circuits, safety relays, safety controllers, master control relays. Many of these features may not be used on every machine, but when used in combination with the default I/O state, they all can add up to safe machine design. So what is the safest output state after all? Well, if you're talking about digital outputs or digital output devices like motors, for instance, usually, but not always, the safest state is off. For an analog output, there's usually a little more variability there. Sometimes with an analog output, the safest thing to do is to leave the value unchanged. Sometimes you want the value to go to a known value, maybe minimum or maximum or even a mid-range value in some cases. Now, if you're going to set the default I/O state in the OCS beyond the normal, then how do you do that? Well, you would do that as part of the hardware configuration. So go into hardware configuration and then drill down to the output, whether it's digital or analog, dialog box for each I/O point that you want to adjust, and you'll find the location where the default I/O state can be adjusted. All right. Now for digital outputs, by default, if you do nothing, they'll turn off. Analog outputs, by default, if you do nothing, they will hold their value or hold their current value. Now, what are some scenarios where you might want to change the default I/O state? Well, let me give you an example of a centrifuge control. Now, you're not necessarily going to do this on every centrifuge control, but it's just one scenario I want to mention. So for example, let's say you have a centrifuge with a control system that has a number of safety mechanisms built in, maybe a safety relay and an e-stop circuit and some other things. So you feel the machine is safe. But let's say that, for instance, you would like to adjust the default I/O state of the main motor output, the one that causes the centrifuge to spin. Let's say you want that to, by default, hold its state when the controller's in idle mode. That way, let's say, if you're going to do a routine program change, and the motor happens to be running when you do the program change, and again, you're not doing an online change, but you're doing a standard download, during that period of time, during the download, you can set it so that that one output that's controlling the motor is holding its state. Why would you do that? Well, that way, the motor doesn't have to spin all the way down and spin all the way back up again, just because you're doing a short download. Okay, so that's one scenario where you might change the default I/O state of a digital output. When might you change the default I/O state of an analog output? Well, let's talk about a temperature control application where you're doing heater control. So let's say that the analog output is the control variable for the electric heater, and by default, the analog output is going to hold its value when the PLC is not in control. But maybe you think it's safer for that analog output to go all the way to minimum to turn the heater all the way off when the PLC is not in control. That's a perfectly valid approach. So you can set the default I/O state of that analog output to be minimum. Now let's go ahead and take a look at how we can adjust default I/O state in Cscape and then what it looks like on the bench. Okay, let's start our demonstration here in Cscape. As I mentioned before, to adjust the default I/O configuration settings, or at least the default I/O state, you need to go to Hardware Configuration. So for the local I/O, we click on the Local I/O tab, the Config button, Module Setup, and then for this particular OCS I have here, I have digital outputs, but I don't have any analog outputs. So I'll have to demonstrate the analog outputs on some remote I/O I have here on the bench. But let's start with our digital outputs. Okay, so here at the bottom, it shows you the output state on controller stop. So this is the default output state we've been talking about. And what I have done is I've adjusted the first three outputs that are built in. All right, now by default, all outputs are off when the controller is in stop mode. Okay, so the default I/O state is off. But what I've done here is I've left it at default for output number 1. I've configured output number 2 to turn on or to be on whenever the controller is in stop mode, which is unusual. And then for the third output, I've configured it to hold its state. So if it's on, remain on. If it's off, remain off. So that's what I've done on these first three outputs. Okay, now let's take a look at how we can adjust default I/O state for remote I/O. In this case, I've got a base of OCS I/O on CAN 1. So I click the CAN 1 tab. Here's my OCS I/O base. Now I have a relay output card here in which I've made really the same adjustments to default I/O state here as I did on the built-in I/O. So I've configured the first one to remain at the normal, which is off, the second one to turn on, and the third one to hold state. Okay, so that's really an almost identical configuration to what I did on the built-in I/O. Now this particular base also has an analog output, and I can go ahead and double click here and go to the onboard I/O tab, and here I can see that for my analog output that I have on the base, I've configured it for 0 to 10 volts, a data range of 0 to 32,000, and then the default I/O state when the PLC is no longer in control right now can be adjusted. The default is current, which is the same as hold last state. You can also set it to go to minimum, to go to maximum, or to go to median, which is basically mid-range. So I'm going to go ahead and select median, which is mid-range. All right, so that's how I've configured this analog output to react when the PLC is no longer in control. All right, so that's it on the Seascape side. Now let's take a look at the bench. All right, so here's what I have going on the bench. I've got my XL4 here. All right, and its built-in I/O is connected to this handy-dandy I/O simulator. So 8 inputs in the form of 8 input switches, 8 outputs connected to LEDs. I've got a couple of analog inputs that are wired as pots into analog inputs here. All right, so those analog input values are going to be read by the XL4 here through the analog inputs, and that's basically what I have going on. Now, from a logic standpoint, I've configured everything so that this first switch, the status of this first switch, will cause all those first 3 outputs either to turn on if the switch is on or to turn off if the switch is off. Just got some ladder logic to make that happen. All right, so let's turn those outputs on, and then let's stop the controller. All right, what happened? Well, first of all, we can't look at the status on the screen because the OCS is no longer scanning the I/O. So we have to look at the indicators. The first LED is off because it was configured to go off on default I/O state. The second one is on because it was configured to turn on. And the third one held its state, so it's on. All right, if we go back into run mode, we haven't changed our switch, so all 3 outputs turn back on and again are under OCS control. All right, if the outputs are off when we go out of run mode, okay, again, first output turned off because it was configured to do so. Second one turned on. Third one held its state. All right. And now that the PLC is back into control and the switch is off, all 3 are off. Okay, now let's take a look at what's happening on the remote I/O. So I'm going to switch screens here. All right, and here's what I've got happening. First of all, we can turn our attention to these LED indicators here above my right index finger. Those are for the first 3 relay outputs on this card that I have adjusted the default I/O state for. All right, so I've configured it the same as what I did the built-in I/O. All right, so these follow the switch. Okay, so all 3 LED indicators are on over my right index finger. They're off, they're on, they're off. Okay, now, in addition to the PLC going into stop mode, we also could lose network communications. All right, that's another possible scenario where the default I/O state comes into play. So let's pull the plug on the network. Okay, and very quickly, you can see we've lost communication based on the flashing LED. The first output is off as it's been configured, the second one on, and the third one held its state. All right, let's return or resume communications. And a few seconds after I plug the cable back in, we should have all solid for communication. And then once again, the outputs are following the switch. Okay, now let's go ahead and take a look at what is happening with the analog output on the remote I/O base. And to do this, I need to get my multimeter. Okay, so here's what I have configured from a programming standpoint, a ladder logic standpoint. All right, so remember, these 2 pots are wired as analog inputs to the OCS here. So what's happening in logic is the OCS is passing the value from this first pot directly over to the analog output register that's controlling this analog output. You can see that digitized value there. All right, and this value on my multimeter is the voltage. It's a 0 to 10 volt output. You can see my voltage going up. And then as I turn around the other direction, you can see the voltage going down. All right, so let's stop here at about 7.95 volts. Okay, so if we lose communications over the network, let's see what happens with our analog output. If you remember, we configured it to go to median, which is about 5 volts. And sure enough, you can see my multimeter says 4.97. So that's about 5 volts. All right, let's resume communications. And after things come back online, we should see that analog value returning to where it was before, which is a little less than 8 volts. All right, so that's the demonstration on how you can adjust the default I/O state for digital outputs and analog outputs, whether they are built in or whether they're remote. So this is the part of the program where I remind you that we're here every Tuesday at 2 o'clock, whether we're fully live or whether we are pre-recorded. But we're here every Tuesday, and there's always somebody standing by to answer your questions in the chat section. And if you're watching on replay, there'll be folks who can answer your questions. Just give us those comments and questions in the comment section. Okay, our training schedule has been established for 2024, so don't forget to sign up early before those time slots get filled. Okay, so as I mentioned in my intro, the next 2 weeks, we're going to take a look back and a look forward. So don't miss those programs. And then the rest of our programming for January of 2024 will follow and be announced on our website. So check that out. Well, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do us some good.